check out
Oh, yeah.
answer. It's like 3.
I don't know. Wait, I can also do it.
Alright, stop.
Hey, can I take
Okay.
a test?
What?
Can I take a test?
Yes.
Literally not.
There we go. Nope. Cell phones in the caddy if you have it ready.
Oh, right. I'm putting it down. He's stuck on my thighs. After Ryan. Ryan, we put these in the caddy.
So what? Why would you do that?
No. That sounds amazing. I wish I was sitting there.
There you go.
Hey, Ward, is today a free day since we just
No.
test?
Okay, go sit. Sit, find a seat. Straight to the You're gonna need all the time you can get. You only get the one class per week. Yep, put it right there. Alright. Hey, real quick. We're gonna go through a couple notes today. We're gonna go through test scores on Monday. The reason why I want to go through them one more time to make sure I didn't make any major mistakes, and plus I have actually 2 kids that still need to take it, and it would make sense going over the answers. So, alright. Actually, 3 kids have to take it still. We're going to go through those Monday. Now, I'm waiting till Monday to put them in the grade book. That way, you can actually retake it, because otherwise it looks like it's on this midterm. So there's a rhyme and reason to my madness right now. So, let's walk through a couple different problems today of what we're going into. If you have your notes out, there's a couple different things we're going to discuss. But the first thing I need to hand to everyone is some graph paper. I don't know if you received graph paper from me. I would assume you didn't. Okay. This is going to be a part of our notes. Do not get rid of this. What makes me more mad is I hand these out and somebody loses it after day 1. So, because you only get one of these, I'm not going to hand out a bunch of them because I need them for homework. Alright, so we're going to discuss. We're going to go through all these different parts.
Yeah.
Alright, just the 2 of you over here.
Yo, get it.
Is there a third?
I'm gonna get a second.
No, you're not getting a second. I already told you.
Cool, where's your jersey at?
I forgot to get it.
It's not good.
Yeah, it's bad.
That's
Alright.
still processing my
So, lunch, I bet you're gonna shoot knock it out.
Colt, you want ball line?
gonna yell at you.
You Colt didn't get his jersey. Or his pants.
He doesn't play.
Jake says he has to go to the bathroom.
Hey, internet.
My son Drew. You had it.
Why are you better than what I do? Literally.
Yeah, he loves it. Alright. Hey, here's the idea. Today, I want to make sure that we get to see the different types of math relations, and then talk about what we're going into in this new chapter that we're starting. We are actually properly starting chapter number 1, other than all the prerequisites. I still require that you remember the prerequisites, laws of exponents, how to factor. That's why I spent so much time reviewing that stuff, is because it's a major part of pre-calc, and it's something that's in the middle of a problem that you need to know how to do. You will see that first and foremost when we start graphing like the 2nd and 3rd section. You need to know how to factor. Like, as soon as possible, know how to factor, because it will make a huge difference on the actual answers we have.
Jake, you're
Ah, there we go, okay.
4 minutes.
That's a big mouse.
That means it's a rat.
Oh, it's a rat.
And Colt decides to just chain off.
I'm already immediately regretting not giving you a scene shirt. I can tell you that right now. Alright. One type of relations. We have 4 different types. The goal today is to introduce them, because some of them you have never seen, I can guarantee it. So, what you're looking at here, this is our Cartesian coordinate plane. This is the thing that you do a lot in Algebra 2, you do it a lot in Algebra 1. Cartesian plane, coordinate plane, however you want to call it. This system was created in the 14th century by a French mathematician, René Descartes. We still use it today. It's used in your technology, your cell phones. That's how the dot matrix screens on your cell phone actually works, how when you touch the app, it knows exactly what pixel you touched. It opens up that app because that pixel was associated with some action. So, the corner of your cell phone, like the screen, you can actually see individual pixels. When you touch, it's actually activating that pixel and it's attached to some action that it goes through. But it's a super old system, 14th century. So 1300s, if you think about it, that's a long time ago. And so we still use it to this day. In fact, you can see it when you use Photoshop. They have the little the coordinate plane in the corner telling you what pixel you're actually touching. But it's a simple little action where you can graph to any spot on here by just knowing two numbers. They're called coordinates or ordered pairs. An ordered pair is literally what it says. It's a pair of numbers that are ordered alphabetically. So when you look at an ordered pair, there's two numbers, x and y. Now there is a potential if we go to three-dimensional drawings, like a cube or something like that, they can have three dimensions, x, y, and z, but it's alphabetical. The first number you're picking is the x-axis. Most people know it. All the graphs I've given you, they're already labeled. Now, some people like to turn their paper sideways, like to go kind of like landscape instead of portrait, so it's like horizontal to you. If you're going to do that, if you're that person that likes to turn it sideways, right, you have to relabel the x and y axis, so I know how you're actually drawing it. Okay, usually I can tell by how you wrote your name on the paper, but some people they'll write their name and then they'll turn their paper sideways and start graphing. Okay, so when we get to these certain numbers, let's say like 1, 5, and 8, -2, and 0, -4. Do we even know where to go so you get the right dots? That's what we need to practice right now. Because what you're actually looking at in front of you are two different types of relations. Two of them out of the 4 or 5 that we have. First one are called coordinates. Obviously it's a way of displaying data. It's just written out. Most people just, if they write out data on their notebooks when they're collecting a science experiment, that's data, right? It's like ordered pairs. The second way is a visual way, that's the graph. Now, here's what I'd like to know. How do we graph 1, 5?
1 to the right.
Boom, go draw. Go draw. 1, 5. Okay, somebody want to venture for 8, -2? Who's got the last one? Boom, go. No, you did it fine. You made a question?
Yeah.
That's me every day. I do.
That's alright.
Okay, alright. All three of those are correct. All three. Okay, 8, -2, 0, -4, 1, 5. They're all three different. It's kind of a scatter up there. It makes a triangle. But what you're actually looking at there is data represented visually, right? So if you had some data that you're plotting for your business, and you're actually plotting maybe this is the month and how much money you have, right? So the first month, let's call it like when you open up your business, you have debt, let's say. Okay? You went to your first month, you made some profit because you started selling your product. And then later on, in the 8th month, you're starting to lose money again because you probably had to go buy more supplies, so you had to spend some of your profits. So you're in the losses now, and maybe the next couple months you'll be in the profits again. You kind of you zigzag all the way across. It's a very visual way of looking at it. Some people like to look at the graph. When you go to a bank and you ask for a loan, or you're asking for some type of business, adventure, or you want them to invest, visual aids can help. Maybe this doesn't show the best data for you right now, but maybe it's showing that you're working in an upward trend. Maybe that's what you're looking at. So they can see there is profit down the road. They'll get their payments back. Okay? So those are little things you got to think about, like real world situations where graphs can actually benefit. It's very visual. People like to see something like that. Now, obviously most people know how to graph. You probably did it way too much in Algebra 1, way too much in Algebra 2. That's what I bet.
Yeah.
Yeah? Okay. Here's the thing. We are going to review a little bit. Because obviously, pre-calc, we continue, right? It's an extension of Algebra 2. We look at topics and we go that extra step. Well, what we need to be able to handle, number one, is what is the data? Do we know what it represents? Can we break down a graph into multiple parts? Can we take a formula and apply it to the picture? Those are things we're going to learn in this class. Can you take data and actually come up with a formula that represents that data? Or, for the most part, represents that data? No, can we get close? That's the idea. Alright, so thank you for those three volunteers. It's kind of hard to get up here and do that, but I appreciate it. So, now, here's the idea. Do we understand the two types of relations? Data versus graphing. Most people know this. You've done it a lot, obviously, clearly. Third type. Let me get rid of this graph. We'll come back to the graph here in a minute. There's a rhyme or reason why I had that up there and why you have it in front of me. Third type. We have tables. This is probably the most common way of displaying data in like a science class, okay, or chemistry. You have certain numbers over here. You have certain data that's associated with it. Notice how I wrote it though. When you write a table, it's got to go least to greatest, and then the answer is straight across from it. The y numbers aren't least to greatest. They're just associated with a certain x. But it's least to greatest. Now, why that's important? You're organizing. You're reorganizing the data in a way that now you can see start to finish what's happening. It's not just randomly chaotic numbers. Okay, maybe the chaos was a part of the experiment, but organizing the data, now you can see trends better. Okay, does everyone understand the table form? Tables can be important because you could have multiple experiments going on, and you have multiple different experiments. Where you have stuff like this. Where you have the y, the g, the f functions are all different types of functions that give you different values. Maybe there are different parts of the experiment. And so you had different numbers you were collecting. Because maybe the second column represents time. That when you're taking those data numbers. Seconds that you're dropping, you're dropping a certain tennis ball from a certain height. Maybe the last number, maybe this is the velocity. Maybe that's the velocity you're dropping in. So tables can be, they represent different things because you could have multiple columns go down, but you have the same x numbers, the same row numbers. These numbers are important because the data is across from it. I don't know how many times you had to do that in Algebra 2, but I remember in science classes, when I was doing experiments for science, we had to do multiple tables and see how the numbers were all playing out and give a very visual way of representing all the data in one graph, one table. Does that make sense how tables work? Now, it's nice to know what each of those columns represent, but it's just a very visual way of representing it. You have the same x's, the y values were changing because the experiment was looking for something different. Alright. Now, we're going to come back to that table probably on Monday. We'll talk about it more after we review the test scores and whatnot. Hopefully. Or we'll take a minute. Alright. The last thing I want to make sure of today. The last thing.
Job.
I'd like you to write this down. We're going to put another one up here in a second. Alright. Now, I'm going to get rid of the table. Most people know what tables are. It's just a way of displaying data in a very compact form, other than visual. What you're looking at here is, it looks like it's a coordinate with three numbers, right? It looks like I'm trying to write, like a three-dimensional graph, but you're multiplying two different ones together. That's not what's happening here. well, this is actually called, this is called a viewing window. A viewing window is super important when you're graphing because it centralizes your graph down to a certain box. So that's only the box you're looking at to see your data. Now, how this works. This first box represents my x's, my x-axis numbers. The second grid, the second bracket represents my y numbers. Now, they mean certain things here. So this is, if I had my graphing calculator, my $140 calculator, I could type these in a viewing window mode, like there's an option for it. And so when I go to my graph, this tells my graph what to display on the screen. So it like centralizes really quick right at that spot. Not at the crosshair, not like these, where it's centered over 0, 0, and it's, it's showing you from 12 to 12. It's not doing that, right? It's going to a very certain spot and it's showing the data in a very certain way. So here's what it represents. For my x's, this is the minimum x that I'm using. Minimum. So that's going from -8 up to the maximum number, which is +8. So if I was on a graph, an actual graph, I'm going up to 8 this way, right? And going down to -8 this way. Now, this last number is the units I'm jumping by. I'm jumping by ones. That's pretty much normal. I mean, that's the graph you're kind of looking at in front of you. That default graph you're actually looking at on paper goes 12 by 12. And it's jumping by ones. But you can rename it. You can take that graph, because I didn't put any numbers there. You can make that table, or that graph in front of you, any numbers you want. You can jump by 2s, by 4s. You can jump by anything. But these are all by ones. So that's 1 up to 8. This is -1 down to -8. So you can see that it's jumping by ones. Now, the second bracket here, these are my y numbers. This is the minimum y number that I have. Minimum y number. -2, that's what it will display. It may not show it on the screen, but -2 is where I'm starting. It's going up to 5, this is my max. It may not show that on the screen, I'll explain that concept here in a minute. And it's jumping by 3, so this is the units it's jumping by.
Can you jump by a different number of y's than you are x's?
Yeah, oh yeah. So on this, what I said earlier, when I type this in my calculator, it may not display -2. My screen might just show this. And and by knowing that unit, that viewing window, this spot right here, that's -2. Why it's not going to show it as a hash mark is because it didn't fit the scale by units. I'm jumping by 3, so it's not going to show a marker. And the other side, it would actually cut off right at -8 and right at +8. So this is what my windows would look like on my calculator screen. You can do this in Desmos, you can do it in other types of graphing units. Now, going up, I'm going up to +5. It may just show this, where this is 3, and 5 is at the very top. They didn't tell you that, but 5 is right here. And that first marker was a 3, because it's jumping by 3s. Every mark that they show is by 3s. Does that make sense what it would show on a calculator screen? Why that's important? Because maybe I just need to look at certain data for that month. Maybe that's what my investors are looking at for my particular business. They want to know, how do you do in the last 8 months? How do you do in the last 6? Okay. All right, here's what we're doing today. We're going to talk about graphing today, but it's not what you think. We're not like graphing lines or anything like that. We're talking about like different ways of displaying data.
Are we still in the P chapter?
No, we are moving on to chapter 1. Full on chapter 1 now. We're going to look at test scores on Monday. We still have people that take the test. There's others. But we're looking at Monday. I'm not going to enter it in the grade book until Monday, because if I enter it now, like your score, it's technically before midterm, and you wouldn't get to retake it. So there's reason to my madness. I enter it as a score on Monday,
Then
you have a week to retake it. So there's a rhyme and reason to my madness. So, all right.
don't
Yep,
question
you have to take a
logic,
retake
you're
last
right.
week.
Oh, okay.
Now, here's the idea. What we're going to talk about today is the different types of relations. how you can display data to somebody in different ways, right? So the different types of math relations are the part that most people understand. Like for instance, what you're looking at in front of you is a Cartesian plane, Cartesian coordinate plane.
Who invented it?
Chapter 1. 1-1. Sorry. Section 1-1. So Cartesian coordinate plane. Now, here's the idea. Obviously, when we're talking about coordinate planes, we're talking about coordinates themselves. Or, better terms, is called an ordered pair. Okay, I'm going to put that in air quotes. Alright, now, here's the idea. These are two forms of displaying data. Obviously, you have the graph in front of you. The graph paper I've provided you is just a part of your notes. When we start graphing stuff today, I'd like you to graph on your graph paper as well, so you get some practice and you get to see some different examples. Don't lose it after day 1. I'm not going to hand you another one. Because I'm not going to waste a bunch of them because we're going to use some on homework anyway. So you only get one. If you lose it after today, you're going to have to draw everything by hand from now on. Okay? So, now the coordinate plane, this is a 14th century math concept. It was made back in the 1300s by a French mathematician, René Descartes. Right? We still use it. Your cell phone that you have, the touch screen, the dot matrix screen on your cell phones use this system. So when you're touching the corner of your screen for an app, it's like the coordinate plane. It knows what pixel you touched, and there's an action that's behind that pixel that tells the phone what to do. They're just mapping every pixel to what your touch is. That's why the more pixels, the more accuracy you have. Because now that icon, that app that you're using, is spread over more actual like pixels. So when you touch, you're hitting a group of pixels, and that's better for accuracy. It's more responsive. Like there's a ton of math behind all of it, right? But this is the concept, right? It's 14th century, 1300s. This thing was created, but we still use it because it's super easy to understand it. Now, it's a way of displaying data. Now, obviously, the data we're used to are coordinates, right? So a coordinate is something like this, or this, or that. So here's a bunch of different examples of coordinates. Here's what I like. I need 3 volunteers, 1 person at a time. Come up, draw one. Pick up a pencil, do the first one. Or a pen, mark. Okay? Who's got the next one? Boom, go up. Third one, who wants it? Otherwise I'm going to volunteer somebody. What's it? Perfect. Nice catch.
No, I'm doing this one.
Okay.
I do what I want.
Brody, that's.
Brody did the last one.
Brody.
Oh, Brody, which one are you doing?
Brody, you know?
1-5.
That's 3.
I swear I counted 4. It's like 7.
Yeah.
Stop throwing it, Brody.
1, 2, 3, 4. You got it?
Alright. Put that marker back on. Stop throwing that. Sorry. Boom. Alright, so go sit. Thank you for those volunteers. It's not easy to do that. Alright, so we've drawn them. They're all in the right locations. Now, here's the idea, right? You guys know how to graph. You know how the coordinate planes work, right? The ordered pair. It is literally called an ordered pair because it's alphabetical order and they are a pair of numbers. Now, the x-axis numbers go first, y numbers go second. Fine and dandy. Now, why this is important. If you're in a business and you're plotting data over the months, and you're plotting what your sales are or what your profits or losses are, you know, at month 0, this is your initial amount, right? This is what you're starting your business at. You're in debt. You borrowed money from the bank, maybe you still owe $4,000, right? You went to your first month, okay? You went to your first month. Okay, you got passes for me? Perfect. Just put it in the back. Okay, alright. The first month, you made it to 1,5. You're already $5,000 in profit. The 8th month down the road, you're already in losses because maybe at some point you had to buy more product, so you had to get another investment. You went into the negative for a little bit to buy more product, and then you're going to sell them again. So maybe the next month you start selling more product again. You're up. This is an upward trend. right? It's a very visual way of displaying data to somebody because you can actually see what's happening. This is a normal business, right? You spend some money, you make profits when you start selling your product, you spend a little more money, you lose a little bit, you start spending. But the goal is, in the long run, can we get to a point where you're getting closer and closer together, where it's just straight profit from then on out? That's kind of the business model, right? That's when you think about like shows like Shark Tank and other things like where, where they have angel investors that have a lot of money.
What's his last name? Kevin.
I don't know.
He's my favorite.
All right. So, but here's the idea, right? Those shows are based on a very simple concept. When you're on that show, they ask very specific questions. They ask, obviously, what is your product and what does it do? But number one, what are your sales like? What are your demographic you're shooting for? How many sales have you made up to this point? Because what they're gauging with their very specific questions, they're gauging where are you currently sitting right now? Are you in profits or losses? How many have you sold? Did you make a lot of money on your product? Is there potential for that? Does it cost a lot to manufacture? So they're looking at little numbers where they're trying to iron out how long will it take you to be profitable. Because they don't want to see profitable 10 years down the road. They want to see it in about 2 months. And they want to see, can you get there? If they say huge potential because you're the only one in that market space, or the item is so cheap to manufacture versus what you're selling, they love those opportunities. That's why Apple bought Beats headphones, right? They bought them back in like 2008 because Beats cost like 20 cents to make it.
Actually,
And they sell them for $150 for a pair of headphones.
3 to 4.
Yeah, well those for the big ones, right? They saw instant profit in that market, and they saw that people, it was like a style icon, right? It was fashionable to have them. They saw potential and they went with it, right? That's a super smart investment. They made their money back on that sale in the first month of owning that
So
company.
Beats is on Shark Tank?
No. I'm saying that idea what Shark Tank does is exactly what most companies do when they buy other companies, right? Shark Tank is just a more public way of doing it, right? But the idea is that you're seeing data in front of you. It's very different. Seeing numbers is one thing. Seeing the visual representation is a complete other. Why this is helpful? I want you to see past just the X's and O's and the X's and Y's on the screen. I want you to see that there is a potential in business to actually use some of this stuff. Right? It may not be exactly what you're seeing here, but there is an actual reason why we do it. Now, we're obviously in this chapter, we're going to be looking at other things we can do. Like obviously, like one of the things I want to eventually get to is if I give you a formula, can we graph that without a calculator? A random formula. Do you even know how to break that down and look at little pieces so you can graph it roughly correctly? Or vice versa, if I give you a graph like that, can you give me the formula that will roughly give me that back?
Isn't that rise over run?
No, if it was linear it would be, but if it's a curve where it's going up and down, that's a completely different formula. Right? Now,
I remember.
that's what I want to do. That's why in that first chapter, I had you reviewing how to multiply. I reviewed how to factor, because those are big things from Algebra 2 that we're going to use. Like, they're not going to go away. Those are going to be in the middle of a problem on one of the steps when we start graphing. That's why we start to review that stuff, so you're not lost completely when we get there. Some people are still not great at factoring. Fine. We're not going to leave it, we're not going to let it go. We're just going to get better and practice it more so that you can be more proficient at it and why we use it. That's kind of the key concepts, because most people lose that. They lose like, why do we even do that stuff? Yeah, there's a specific reason. You're just getting it later, right? This class is really just built upon taking Algebra 2 and going one little extra step in each case.
Is that why it's called PreCalculus?
Yeah, I mean, we're literally, before calculus, we're just building the concept. Can we connect Algebra 2 to calc? Can you connect trigonometry, study triangles, to calculus? Can we see that there is an actual progression there? That's what we want to do. Now, obviously, this is the first step. Most people know this stuff, right? We'll come back to this later. Now, the third way of displaying data, other than just coordinate pairs, set of ordered pairs or Cartesian coordinate planes like graphs, one of the other ways we've been displaying data is a table. A table is a very specific way of displaying data to somebody. It's organized in a certain way. If I went back to those coordinates I gave you, 1, 5, 8, -2, and 0, -4. If I took that data and I want to go to a table, you take your table, you break it up into X's and Y's. The X's have to go in order. Most people forget that. When you do a table, it has to go least to greatest for X's. So you have to go least to greatest. So that's 0, we had a 1, and we had an 8. The numbers go straight across though. So for 0, we had a -4, 1 we had a 5, and 8 we had a -2. I don't care that the numbers on this side aren't going in order. It's this side was the important side. Now, why that's important? This now put in perspective order of numbers now. You're ordering data. You're taking all the experimental stuff you did in a project, you're now labeling it in order so now you can go graph it. You can go do other things with that data. It's just an organizer. But what most people forget about tables don't just have to be X's and Y's. You can have other functions that are a part of this table. And maybe these are different data sets. Maybe there's different data sets we're going to get for that G column or the F column. Maybe this number was even more. Maybe in that G column there, this column represented the time it took for that. Maybe you're doing like a ball drop experiment. Maybe it was the time it took the tennis ball to stop bouncing. And the X's are the height you dropped it from, or maybe that's the time on a column. Maybe that's the height from the object you're going from. Now 0 doesn't make sense, but you get the idea. Maybe F was the speed that it traveled. Like there's different data sets. Each column can represent something else, but for whatever data you're collecting. But these X's don't change. These X's are the X's you use to find these numbers. They just happen to be the Y, G, and F column, just happen to be different parts of the same data set. They're just, from X of 0, you collected 3 pieces of different types of information about your graph. It's just organizing it very quickly. So now you can go and you can graph from there and do other forms. It's one of those things that a lot of people just don't understand, that you can go do that. Okay, do we understand the third type of displaying data?
Easy.
Okay, next thing. If we go back to this order pair, this Cartesian coordinate plane idea, right? What most people tend to forget is that sometimes the data, you collected all this data, maybe the data only makes sense if you look at little pieces of it, right? So here's the other concept. So let's take a look at this part right here. This is the part I'd like to write in your notes. Okay. -5, 5, 1, 2, 8, and 3. Okay. Sorry, -2. All right. So what you're looking at here. This is going back to the coordinate plane. Now I'm not doing 3-dimensional stuff. What you're actually looking at here is a viewing window. This is how you can take data on a graphing calculator or like a graphing program like Desmos and replace the dimensions of those windows. This is called a viewing window. And so that you can look at very specific data and a very specific window of where your data is trending in that spot. Now, what you're looking at here in this viewing window is very, very specific. Okay, so here's how it works. These represent your X's. These represent your Y's. That's what you need to know first. X's and Y's. Okay? Now, in the front, in the X...
pair off?
What?
Don't the first 2 pair up, the middle ones pair up, and the back ones pair up?
No. So here's how it works. The first number here, this is a minimum. It is the minimum X you're going to use on your graph. The second number is the maximum X you're going to use. I got to record this part. All right, because this is the part where I stopped earlier. So, here's the idea. Intercepts, where I hit the X and Y axis, you guys already listed those. Now, I've talked about if it's continuously flowing or not. This graph I have right now has dots. It is not continuous. Now, if you were to have a viewing window, where maybe the viewing window went from, I'm going to put the little grid here. Maybe the viewing window went from 2 to 3, and it went by ones, and it went from 0 to let's see, 0 to 4, let's say. And it's jumping by 1s as well. Let's say that's my viewing window. I'm going to draw a box in red, right here, red, that represents that viewing window over this graph. Like what your graphing calculator would probably show you. It's going to start at 2. It's going to go from 2 to 3.